Welcome to saitechinfo, dear UPSC, TNPSC, NEET and JEE aspirants and school and college students.
In today's session, I will be explaining about mutual induction. Let us consider this coil. We have got two coils. The first coil is primary coil, coil number 1. And you have got coil number 2. So we have kept two coils nearer to each other. The primary coil consists of more number of turns of coil. Means N1 number of turns, N1 turns of coil. Secondary coil that contains N2 number of coils, that is N2 number of turns of coil, N2 turns of coil. Usually the secondary coil, the number of turns in secondary coil will be less than that of the primary coil. Now here we are giving the current I1. So when we give current here, since the current is passing through a coil, a magnetic field is created. That magnetic field created will be inducing what? The nearby coil, that is the secondary coil. So, and that is responsible for phi to 1. Phi to 1 is nothing but the magnetic flux of the secondary coil with respect to the first coil, that is influenced by the first coil. Got it?
Yes.
Now, so since magnetic flux, that is passing through that, it undergoes changes. When there is a change in magnetic flux with respect to time, there is an induced EMF according to Faraday's law, and therefore you are able to get E2. What is E2? Induced EMF in the secondary coil. Now because of this induced EMF in the secondary coil, a current I2 is passing through that, and that in turn will induce the magnetic field on the primary coil, and that is given by the magnetic flux phi 12. Are you able to follow?
Yes.
And that is responsible for further induction magnetic field, that is EMF, induced EMF. That is E1. So this is E2, this is E1. This is a phi 21, that is magnetic flux of the secondary coil with respect to first coil. And what about this one? So that is shown here separately. We have got two diagrams. Okay, here I have shown the magnetic field in the first coil, and that is a passing through, that magnetic flux is passing through the secondary coil. Here magnetic field is created in the secondary coil, and thereby it induces the first coil. Okay, are you able to follow? Right. And here I have given the details. Coil 1, primary coil with more number of turns of coil, N1, and current is passed through that, that is I1. Whereas in secondary coil with less number of turns, that is N2, and this is the induced EMF of first coil, and this is induced EMF of the second coil, and this is phi 12, means magnetic flux of first coil influenced by the second coil. And what about this? Magnetic flux of second coil induced by the first coil, and that is why they mutually induce each other, and that is called mutual inductance. Okay, so this concept is useful in designing the transformer. Are you able to follow? Right. Now let us consider. N2 phi 21 is directly proportional to I1. Are you able to follow?
Yes.
What is I1? The current given in the first coil. So the magnetic field, that is magnetic flux, that magnetic flux is induced by the first coil, the current passing through the first coil. It depends on the amount of current passing through the first coil. When you increase the current, naturally magnetic flux will be increasing. And not only that, it also depends on the number of turns of coil, and that is why I included N2 also. Right? Now, N2 phi 21 is equal to, and when you remove the proportionality, you have to introduce a constant, and that is called M21. So what is M21? The mutual inductance of secondary coil with respect to the primary coil. And so I have given the details here. Now M21. So M21 will let us rearrange, which is nothing but N2 into phi 21 divided by I1. Got it? Is it clear? Right. Now let us move to Faraday's electromagnetic induction law. According to Faraday's magnetic induction law, after all, we introduce the lens correction also, minus, that is opposing these changes of flux. Okay, so E2 is equal to minus d of N2 phi 21 divided by dt. So this is the known equation. That is, the EMF, the induced EMF is proportional to the rate of change of flux. What do you mean by rate of change of flux? How frequently, how fast, at what speed the flux is disturbed. That is very important, and that is why when you rotate more frequently or with a high speed the motor, so you are able to get better EMF also. Okay, so EMF is based on the number of turns of coil, and not only that, the change, the rate of change of magnetic flux. And now we can, so we have got N2 phi 1 divided by dt. We know already N2 phi 1 here. Okay, so that can be replaced here, which is nothing but M21 into I. So that I have replaced. Now, and M2, you know, is a constant that can be taken outside the differentiation. That is why E2 is equal to minus M21 into di1 divided by dt. So this is one important equation, and based on that you can arrive at M21. So M21 is equal to minus E2 divided by di1 divided by dt. This is one part. Similarly, we can work out for the secondary one, the primary induction. So here M12 means what? Mutual inductance of first coil influenced by the secondary coil. So that we can work out similarly and can be arrived at like this. So M12 is equal to minus E1 divided by
di2 by dt.
Okay. When M1 is equal to M2, what will happen? So the ratio, that is E2 and the rate of change of current will be equal. Okay. So E2 by di by I1 divided by dt is equal to E1 divided by di2 by dt. So this will be used in problem solving also. Okay. Is there any doubt? Fine.
யாம் பெற்ற இன்பம் பெருக இவ்வையகம் என்பதற்கேற்ப please subscribe if you like our educational contents and share with your family and friends. Thank you for spending your valuable time.